All right, let's simplify some expressions using the sum and difference identities for sine and cosine. So let's say we have alpha is in quadrant 1 with a sine of 7/25, and beta is in quadrant 2 with a cosine of negative 8/17. And we want to find the sine of alpha plus beta. Just jumping right into using the identities, we would take this sine and rewrite it as sine cosine, so sine of alpha cosine of beta plus cosine sine, so plus cosine alpha sine beta. And so far, we've got about half of what we need. I know that the sine of alpha is 7/25, and I know the cosine of beta is negative 8/17. But when we get to the second half, I don't have either of these values. So we go back into the problem and look at what we were given. When we're talking about the angle alpha, it's in quadrant 1. So it's an angle that's right here. Okay? Its sine is 7/25. So its opposite over the hypotenuse is 7/25. With a little bit of Pythagorean theorem, we can see that this is going to be 24. Now, when I'm wondering about what the cosine of alpha is, I just look at my triangle, and the cosine is going to be 24/25. Similarly, when we look at angle beta being this second quadrant angle, we can reference its reference angle right here, and it has a cosine of negative 8/17. A little Pythagorean theorem there tells us that the height would then be 15. Now, when I want to know what the sine of beta is, I just look at this reference triangle, and it's going to be opposite over hypotenuse. At this point, it's all over but the algebra. 7 times negative 8 is negative 56. 24 times 15 is 360. And we have a common denominator of 425. Simplify that down to 304 over 425. And there's our sine. So let's try that again with sine of alpha minus beta. So we're going to use that identity again. Sine cosine minus cosine sine. Then, using the values that we were given, or our reference triangles, we fill in all 4 of these values. The sine of alpha was 7/25. The cosine of beta was negative 8/17. From our reference triangles, the cosine of alpha is 24/25. And the sine of beta is 15/17. Once it's all filled in, we go ahead and do the arithmetic, and again, we'll have negative 56. This time we will subtract 360 all over the common denominator of 425. Leaves us negative 416 over 425. Just for practice, let's do it again with cosine. We use the identity for cosine of alpha minus beta, and that would be cosine cosine. So cosine alpha, cosine beta, plus sine sine. Sine of alpha, sine of beta. Then we plug in the values that we know. Cosine of alpha wasn't given, but it's in our reference triangle as 24/25. The cosine of beta was given, negative 8/17. Sine of alpha was given, 7/25. And from our reference triangle, the sine of beta is 15/17. Then we finish it up with a little arithmetic. 24 times negative 8 is negative 192. 7 times 15 is 105. And our common denominator is still 425. Simplifying, we get negative 87 over 425. So how about tangent of alpha minus beta? Well, there on your identity sheet, there is the difference identity for tangent if you wanted to use that. But after all that work that we've just done, we have a different identity for tangent, and that is the tangent is sine over cosine. And we just did all this work to see that the sine of alpha minus beta was negative 416 over 425. And the cosine was negative 87 over 425. So we multiply by reciprocals, 416 over 425 times 425 over negative 87. Of course, the 425s are going to cancel, so are the two negatives, and we'll be left with 416 over 87. Let's try this again with a couple of new angles, x and y. If we want to find the sine of x plus y, that's going to be sine cosine, so sine of x, cosine of y, plus cosine sine, cosine of x, sine of y. We can plug in the values that we are given. We know that x is a quadrant 3 angle where the sine is negative 8 over 17, so negative 8 over 17. And y is a quadrant 1 angle with cosine of y being 3/5, so 3 over 5. And we're going to need these next two values. So we go back to taking a look at that quadrant 3 angle. Angle x is right here. And in its reference triangle, the sine of x is negative 8 over 17. And with the Pythagorean theorem, we see that this side is going to be 15. Now pay close attention because we're talking about a third quadrant angle, which means this side is a distance that is to the left of the origin, which means its value is actually negative 15. So when we're trying to find the cosine of x, it's not going to be 15 over 17, but negative 15 over 17. And when it comes to angle y, that first quadrant angle, its cosine is 3/5. So Pythagorean theorem tells us the other side should be 4. And now that we're aware of it, we pay attention, and should this value be positive or negative? Well, since it's a vertical distance that is above the x-axis, that is a positive 4. We need to know what the sine of y is, and sine would be opposite over hypotenuse, so 4/5. Now that everything's filled in, we go ahead and start simplifying. Negative 8 times 3 is negative 24. Minus 15 times 4 is 60. Over 17 times 5 is 85. So that will simplify to negative 84 over 85. Now when we want to find the cosecant of x plus y, cosecant is the reciprocal of sine. And we just saw sine was negative 84 over 85. So cosecant is going to be negative 85 over 84. For a little more practice, let's do it again with cosine. Difference identity for cosine is cosine x cosine y plus sine x sine y. Next, we plug in our values. For angle x, the cosine is negative 15 over 17. For angle y, the cosine is 3/5. Back to angle x, the sine is negative 8 over 17. And with y, the sine is 4/5. Now when we simplify this, we'll end up with negative 45 minus 32 all over the 85, which is negative 77 over 85. And if we want to find secant of x minus y, we recognize that secant is the reciprocal of cosine. Cosine was negative 77 over 85, so secant is going to be negative 85 over 77.